there's a lot of like, if I was a data analyst for 5 years, I feel like there's just as many, if not more, like really good skills that I would learn in that position compared to like a PhD that I just have a certificate at the end of 5 years.
This episode of Ken's Nearest Neighbors is powered by Z by HP, HP's high compute workstation grade line of products and solutions. Today, I had the pleasure of interviewing Scott Cole. Scott is technically a machine learning engineer in the fintech space, but he stubbornly prefers data scientist as a title. He studied bioengineering at Clemson University before moving to UC San Diego for grad school, where he developed algorithms and Python packages to analyze brainwave data. Scott then went through the Insight Data Science program, and for the last 2 years, he's been building algorithms for detecting fake accounts on a peer-to-peer payment app. Scott's most known for eating hundreds of burritos during grad school and curating a small database of all their qualities along 10 dimensions. In this episode, we learn the origin of Scott's burrito dataset, how he narrowed his career search based on his interests, and how he's trying to create a data-centric board game. I hope you enjoy our episode. I know I had a blast speaking with Scott. Scott, thank you so much for coming on the Ken's Nearest Neighbors podcast this week. I'm really excited for this one. I obviously was introduced to you through Nick Wan, I saw you on Sliced. I also heard and have analyzed your burrito data set, which I think is very fascinating. And I just knew I had to, if someone put together that data set, I figured they would probably be interesting to talk to on the show. So again, thank you for coming in. And how are you doing today?
Yeah. Sweet, thanks. Glad to be here. It's kind of funny how much that burrito project, I keep hearing about it years and years later. I've stopped collecting burrito data for like 2 or 3 years, but the project lives on, and it was a fun data set, even if the burritos in San Francisco aren't as good as the ones in San Diego.
Well, I think that's sort of the beauty of a data science project, right? Is it lives on beyond the time you've spent working on it, right? It also essentially like advertises for you while you sleep or while you're doing something else, right? I mean, I think a lot of people are familiar with that data set and probably familiar with you because of it. And like you did that work once, again, like 2 years ago, and now you're still, getting awareness, you're getting podcast interviews, you're getting whatever it might be that came out of that, which I think is like a really positive thing for just sharing your work and putting stuff that you're passionate about into the world.
And I'm definitely hoping that some people are just finding good burritos in San Diego. Like I am a little worried if someone might say like, oh, I tried the #1 burrito in your data set and I thought it was a junk. But yeah, hopefully guiding people in the right direction too.
Well, I am planning a trip to San Diego just to tour burritos based on the data set. So whenever I get out to do that, I'll let you know.
Yeah. I feel like I have to offer the caveat where the #1 rated burrito in the data set was Valentine's, whereas like my personal favorite is called the Taco Stand. So I'd recommend you to go to the Taco Stand, and I feel like there's like an important caveat of the data, where the data I was collecting at Valentine's tended to be tourists who were coming to San Diego. So my friends who were visiting, who were in downtown where Valentine's is, they often, it was like their first San Diego burrito. So they had like maybe a low expectations, or low standards, I should say. So I feel like that might have artificially inflated Valentine's ratings. Anyway, that's just like one caveat of the data that.
Well, I base all my burrito decisions on the purely quantitative metrics. So I was only looking at the mass and the length of the burritos.
No, it was fun. Just whipping out a tape measure and seeing people give me weird looks in burrito shops.
Yeah, I wish you'd brought like a scale to everyone. That would have been some next level stuff. I mean, they make pocket scales now for the next when you start measuring all the burgers or something in San Francisco, or all the poke bowls. You can start using the scale.
Yeah. One of my friends actually, a couple years into the project, gave me a scale for my birthday, and so I, for a while, tried to figure out how to balance a burrito on a scale, but it's pretty difficult.
That is hilarious. So, in order to, I mean, obviously, I think that was a pretty good way to get acquainted with you. But for the listeners who are familiar with like the normal structure of the interview, how did you first get interested in technology and data? Was there just a pivotal moment where you're like, hey, this is what I want to do and what I'm interested in, or was it more of a slow progression?
Feel like it was a bit of stumbling around. In undergrad, I started off sort of on like a wet lab um, track where I wasn't really sure what I wanted to do. I was like, oh, I like science and math. So I, was doing, basically encouraged to like, oh, start doing research. And I didn't really know what research was at the time, but I was playing around with some chemicals. Not ended up not being a huge fan of it. Like I felt like, I don't know, I wasn't, my experiments would often like get contaminated from bacteria or something, and I didn't feel like I had a lot of control over it. So what I found that I liked more was um, like a signal processing class that I took, where it was pretty much saying like, oh, we have this complicated signal. Can we deconstruct what that means? And I had also been like looking into brain data at the time. And when I saw the signals in the class, it reminded me of like, oh, there are these brain waves that people see when they record from the brain. And like, I think it'd be so cool if we were able to like understand what that meant. So I feel like brainwave data was what initially got me interested into data science in general. Just like thinking, oh, if we could understand what these noisy signals are, then we could maybe enhance our brains or treat disease or something really cool.
That's awesome. I've been getting a lot more interested in the different brainwave data types. Well, I guess it's all the same. The different frequencies is probably more
Mhm.
apt way to put it. We're reading this book called Altered Traits, and it's about the science of meditation and like what's true and what's
Mm.
not true, and evaluating like the brains of like hardcore meditators or people that practice with different protocols. And it's pretty fascinating. A lot of it is just like debunking that like, hey, meditation is supposed to do this, but it actually doesn't. But the real science that they've uncovered is also pretty fascinating, of like these Tibetan monks that they bring in and how different their brains work than someone who's on their phone or computer all the time is pretty wild. Um, but so obviously you took that a step further and you studied within that domain for quite a period of time. Do you mind kind of walking me through,
Mhm.
from that moment of realizing this is interesting, where did that take you, or how did that provide some direction?
Yeah, yeah, I wasn't too sure or what to do after undergrad other than go to grad school. Getting a real job seemed pretty scary. So I feel like I was on the track of like, okay, I'm in research, I can keep doing more school. So I applied to a bunch of bioengineering and neuroscience grad programs, kind of with this dream of like, oh, I can spend my days analyzing brain data and understanding what it means. Um, so I, yeah, ended up in San Diego, and was in the first year starting to like do experiments and rotate between a few labs to figure out what I wanted to do. And the experimentation part was really challenging for me. Like we had a boot camp at the beginning where we had to record from leeches, and I was just so helpless in trying to collect my own data. And my first rotation was I attempted to do some surgeries to implant electrodes into an animal's brain, and I had to get a lot of help from the senior grad students. So I quickly realized how helpless I was in collecting my own data. So I was like, so I rotated in two other labs that had the like cheat code of grad school where I don't have to collect my own data. We rely on collaborators who send us data and we just get to analyze it. and that sounded a lot more fun. So I I ended up rotating in like a MATLAB lab and a Python lab, and ended up choosing the Python lab. Yeah, partly not so much for the science itself, but just thinking like, oh, if I want to become a data scientist after graduating, after I realized how helpless I was in collecting my own data, it sounds like it's useful to know Python.
That's awesome. And I
Um,
mean, it obviously sounds like you were interested or aware of data science relatively early on. And I mean, it sounds like you weren't interested in necessarily pursuing academia that far. Why did you
yeah.
decide to just like stick it out through all the research rather than and like finishing the
Mhm.
PhD rather than just like jumping out early?
Yeah, it's part of just being intimidated of what is outside of grad school. I trying to find a real job just sounded scary. Yeah, partially, and partially like also just being, I don't know, still genuinely interested in seeing if I can discover something new about the brain. But it was actually funny in one of my interviews before I even started grad school, a senior grad student was giving a talk about how he realized that what he was passionate about was not actually the research, it was actually data science. And I watched his talk and I was like, oh crap, maybe that's me. Maybe I shouldn't be doing this. But I suppressed that thought a little until I got to boot camp. And then, as I mentioned, the failed experimentation reminded me like, oh, this is difficult. I may want another route, and I feel like I got pretty lucky in the lab. I ended up joining Brad Wojtek. He was actually a data scientist at Uber before he became a professor. So our lab was very like data science oriented, and we had this eccentric postdoc who would yell at me for how bad my code was, in a way to build up our skill, and really give us more options out like after graduating. And I'm very thankful for that.
Well, I really like that you that you kind of stuck through it because you enjoyed the pursuit of like information and knowledge. That's something that um, I really like wish I had appreciated more when I was going through school or when I was doing some of these things. I mean, it took me to like the second grad program I did to realize that, hey, like I'm doing this because I like am fascinated with learning, not just a means to an end. And I
Mhm.
think if a lot of people took that approach with their education more, they'd get a lot more out of it, right? It's like, oh, I have to get through school to get a job. I have to do this and that. It's like, no, there's a lot of things that you can do during school that will be very meaningful in a job market or whatever it might be. But you can also find like utility in them. You can also put your own fun spin on them. You can also like enjoy that process. And I just get really disappointed when I look back and I see that my own like transactional nature with education, but then I see other people like trying to do a master's in data science or something like that. It's like, are they really going to learn data science? Or are they going to land a job? Right. And it's like, you can do both and
Mhm.
you can have fun with both. But unfortunately, I think a lot of people are going the other route where it's just like, hey, I know this is like something that will be helpful in a job search. uh, I'm just gonna do it to put it to check that off my list. And like that's a lot of time,
Yeah,
to check a box, right?
I feel like I wouldn't have made it if I got felt fairly lucky in that like, oh, I get to spend my days analyzing data the way I want to analyze data. Um, so that freedom definitely helped me keep going.
I love that. And so, how did you make this eventual transition from academia to data science? I think that that's something a lot of people probably have questions about.
Totally. Um, yeah, my mind shift was pretty quick early on. I wanted to do an internship to get a sense of like, oh, what is work like outside of academia, and I did a short one about 3 months, with a place called Crime Lab New York. Um, where it wasn't like a company or anything. It was a small organization, actually part of University of Chicago, but it partnered with local city governments in order to like analyze data for them. And my project that I got to work on was analyzing police officer behavior and and trying to predict like, okay, which officers are most likely to get an excessive force complaint. And then those are the officers that should get de-escalation training. So the department wanted to allocate those resources really effectively. So it was a fun, cool like data science opportunity, and doing that made me pretty sure like, okay, there are a lot of cool questions out there beyond neuroscience. Um,
That's a
I
pretty
want to do
relevant
something like
one.
that.
Pretty relevant
Oh,
one. Did you do that like while you were doing your PhD, or did you take a break to do that, or what did that look like?
yeah, I took a break. I was sick of looking at the same like rats data for almost a year. So took a few months off, and then went back to finish my PhD another year, and then moved up to San Francisco to find a job.
Excellent. Excellent. And so what was your first well, like what after that, how did
Mhm,
you actually land that first job? Did
mhm.
was like, I think we talked like a boot camp was involved. What did
Right,
that process look like?
right. So yeah, I had heard this bootcamp advertised called Insight, which is takes a bunch of um, grad students disgruntled with academia and throws them all in a room together, and says they all of them want a data science job. Um, so I did that program, which was 8 weeks. They basically say, everyone, you need to work on the project. And we work together, which is a really cool atmosphere to be in. Just a bunch of people in the same situation, not really sure like what data science is yet, but really hoping to get a job. Insight brought in data scientists from a few dozen companies to tell us what their work was like, to give us more of a sense of, oh, this is what working at a startup is like, or a fintech company, or a consultancy or something like that, which really opened my eyes to the possibilities. Before that, I kind of only knew of like, oh, I could be a data scientist at some big name company. I didn't really know much about yeah, other options. Um, so in that boot camp, we were pretty a lot of us just really eager to get any sort of job. Um, Interviewing for months is not fun, and we all commiserate with each other. Um, so after that, my first data science job um, was at a TV analytics company that I found through Insight. That that was cool. I really enjoyed the team I worked with, but after a few months, sort of figured out that I wasn't really passionate about what I was doing, like or, organizing TV data in order to make ad targeting better, um, and started thinking of like, oh, well, like, what else could be out there? That was actually triggered by my manager at the time. She decided to leave. So when she left, I was like, oh, maybe I'm not as into this either. And I was really lucky that one of the guys I had met when I moved to San Francisco was worked in fraud detection for a fintech company, and was like, "Hey, we have open positions. You should come help us fight fraud." I was like, "Oh, that sounds fun." So yeah, after a few months, I jumped to there, and I've been doing fraud detection ever since.
That's awesome. Well, you told me offline that you probably never saw yourself working in fintech. but you kind of fell in love with fraud detection and that type of problem. How
Mhm.
do you find problems that you're interested in solving? What is that process like? Or like, how do you go about finding things that are interesting to you? You recognize that
Mhm.
the work of the TV analytics company like didn't really scratch your itch, but how do you
Right.
go about, again, finding those areas that you do find interesting?
Yeah, I'd say it's not a conscious thing I do, but more just like thinking throughout my life, what are the things that I enjoy and identifying like, oh, there's a job opportunity there. So I've always, I don't know, felt like I enjoy like seeing systems gamed or hacked slightly. So like creating like I've created like fake profiles on websites and just like found that process funny. So the concept of someone like making fake bank accounts and stealing money kind of like seemed like a game in some sense of like, oh, can I like outsmart this person who's trying to like trick the system? Um, I had heard a talk in grad school of someone who did fraud detection. And I was just like, oh, that sounds fascinating. Another thing that I'm interested in is like online dating data science, just because like I've felt like I've personally heavily relied on online dating to meet people because meeting people in real life can be difficult. And I really like the
Especially
idea of
now.
exactly. Uh, I really like the idea of there being like a database with these like properties of people who like may end up being like really good matches with one another. I think that that is likely to like build a lot, like potentially a lot better relationships than just like whoever I can randomly meet throughout life. So like that is one thing I'm thinking of like, oh, if I could contribute to the algorithms that help people meet each other, like that's another area that I'm really interested in. But yeah, I don't think that there's any like systematic way I identify them, but just sort of keeping my eye out for what might mesh with my interests.
I really like that. I think, again, we talked offline, and one thing you mentioned to me is that you started looking for positions after the TV company based on
Mhm.
what your interests were, not the other way around. You weren't just looking for another job. You were looking at a position that would be able to in one of those spaces. And it just so
Mhm.
happened one of them was at a fintech company, right? And this opportunity came about. Can you talk about maybe the importance of that for you and how that maybe might have been a little bit different than your first experience when you were just trying to land a job?
Yeah, I think part of my motivation is laziness in some way, where when I first wanted a job, like I just wanted to stop studying, and I was just like, I would just want this interview process to be done and find like something that's reasonable. Where like one of my top priorities, along with something I'm interested in, is just having like a team that who I'm comfortable with and working with nice people. Like that will at least like make my life, fairly happy. Whereas once I had a job, my laziness becomes like, okay, I don't want to interview so much. I don't want to like look for so many different companies. I want to really limit my scope to like two positions that I'm especially interested in. Um, so yeah, that's why I was figuring, okay, I only want to look at fraud detection companies right now, and if they both reject me, then fine. I'll once I work up the energy to apply to more companies, then I'll look into something more.
Well, it's interesting. It's a really important point I think you brought up in terms of like efficiency and like sort of laziness is that a lot of people think it's most efficient to just apply to a bunch of companies and see what hits, right? It's like, oh, I can send out this generalized resume, whatever it might be. I actually think it's the opposite. I think if you're applying very specifically in a niche, one, the projects you do or the way you prepare can be a lot more specialized, which gives you a significantly higher chance of getting an interview or landing the job. But two, like, you know, you're able to like hone in and it essentially work less than trying to please everyone. You're just trying to please a couple in this specific space, and you can get so much more specific with your language and your resume and these types of things that I think it's actually as you mentioned, like way more efficient to do that, like figure out exactly what you want and cater everything to give you the best chance at those fewer positions than to just spread yourself so thin. Because then, like, just as you described, you have to prepare for all these different types of interviews, you have to do XYZ. I would imagine that fraud detection interviews, right, they're probably more similar to other fraud detection interviews than like a broad generalist data science interview, right? And so if you know that, you can prepare for those things, right?
I think in the future it would be actually in the uh, interviews I ended up doing for fraud detection. It was just a general like data science pipeline. Um, but I think as like someone gets more senior and like specialized in fraud detection, it'd probably be that way. I think one thing that's really yeah, important to couple with like applying to my interests is also applying to like what is like available and heavily recruiting. Like I had mentioned, probably what my first choice was actually was like working in algorithms for online dating. Like I wrote a passionate cover letter and applied many times to Coffee Meets Bagel, a dating app to work for them, but they were just never looking to hire like a data scientist in my like that something that I wanted to do. They were more looking for data engineers. So no matter like how much I bothered their employees with how interested I am in working with that, they were I don't think ever going to hire me. So yeah, in addition to like yeah, finding what we're interested in, also like keeping our ear out for okay, what companies like are like specifically hiring.
Yeah, well, I mean, there's obviously a lot of constraints like geography, right? I mean, you could work at I can't remember what some of the other ones are. I think one of them, one of the other dating apps is in based in New York, right?
Mhm.
And it's like,
Okay,
well, if you
Cupid.
didn't, yeah, if you didn't want to go work in New York, then you should probably write that one off and and not try to apply there. And there's deceptively easy ways to narrow the search
Mhm.
um, that make it like more manageable for you to do and give you, in my mind, significantly higher odds. I would like to ask and get into what you find. So obviously you described why you're so interested in fraud detection, but
Mhm.
getting into more of the weeds about fraud detection, I think would be pretty interesting. You described it as it's like a very interesting space with constraints that I hadn't considered. Do you mind just going
Mhm.
into that just a little bit?
Yeah, yeah. So when I was first like realized I was interested in fraud detection, I feel like you're saying, I didn't really know exactly what I was getting into when I was Googling online, like fraud detection data science. Most of what I was able to find were saying like, oh, you need to do anomaly detection and you need to know how to like work with imbalanced data. And I really struggled to find like more descriptions other than that. So when I was interviewing and I was saying, wow, I'm really interested in fraud detection, there's part of me that's like, do I know what I'm getting myself into? And yeah, over the past couple years that I've been working on it, there's definitely been like a lot of cool like realizations and considerations that yeah, that I've realized that I wasn't aware of before. I feel like the principal one is the like evolutionary nature of fraud, where once we put out a model to stop fraud, it's going to find a way around that. And it's pretty like it's a huge challenge to machine learning because no matter like how fancy our model is, if the training data is not representative of the evaluation data, then it's not going to perform very well. um, and so there's a lot of like considerations that we need to like keep in mind and knowing like, oh, the fraudsters are going to be reacting to these models.
And
And
how
that
do you
so Mhm.
sorry, how do you design a model that responds quickly? So like I'm doing a video this week
Mhm.
about what happened with Zillow, right? Where essentially there's a lot of problems with what they did, but you know, the pandemic came and their models were not apt to handle what's happening in a global pandemic. Like the changes in the real estate market happened more quickly than previous times, and like I think it's their fault for not pulling the plug, but at the same time, like their model was not designed to rapidly adjust and iterate quickly like that. what are some things that, and digital transactions are different, like scope, right? Like they
Mhm.
do happen quickly. You do have more data, but what can people do to like make sure their models are up to date in a reasonable time, aside from just like constantly retraining? Like, how do you balance that task?
Yeah, I've watched a few talks online to get a sense of like, oh, what different companies do, and what you're saying, model retraining seems to be the most common solution, where just maybe every day, every week, every month, uh, retraining the model so we have the most up to date information, and also. Um, Another approach that I've heard mentioned is like looking out for anomalies. So, is there like some new suspicious behavior that a company's models are not uh, picking up on? Like if they have it at like a complementary anomaly detection framework, then that can help them like realize quickly, oh, this is um, how the fraudsters are getting around their models.
That's awesome. And is fraud detection like an almost entirely automated task, or is it like a hybrid task where it's like there are humans evaluating things as well?
I I'd say that humans are very important, and that's how a lot of fraud detection like has been traditionally done before machine learning or even data analysis was a lot of manual reviews, because it can be like really tricky and ambiguous, like what is fraud and what is not fraud, like how do we craft our labels. And yeah, that's a very non-trivial problem, because how to get those labels. So, for example, in financial like transaction data, there's the concept of a chargeback, where someone reports a transaction as fraud, but not all of those. Like, people are dishonest sometimes. I uh, maybe I regret spending $500, so I'll call my bank and say, "Oh no, that was fraud." Um, so filtering out things like that um, is something that a human can be a lot better at, than an algorithm. Or i- in the future, we'll work on making like the industry as a whole. Will work on making algorithms better for that.
This episode of Ken's Nearest Neighbors is brought to you by Z by HP. HP's high compute, workstation grade line of products and solutions. Z is specifically made for high performance data science solutions, and I personally use the ZBook Studio and the Z4 workstation. I really love that the Z line can come standard with Linux, and they also can be configured with the data science software stack. With the software stack, you can get right into the work of doing data science on day one without the overhead of having to completely reconfigure your new machine. Now back to our show. So, you talked a little bit about people lying about their transaction history because they're embarrassed, and there's some of the malicious behavior that goes on with fraud.
Mhm.
You told me that you're pretty passionate also about people lying with statistics, right? And I'd love to hear more about how people do that when that happens, and what are the repercussions associated with that.
Yeah, one of my favorite books was, I think it was written in 1952, with the title like "How to Lie with Statistics," and it's a fun, like mostly picture book, where this guy is basically ripping into newspapers written in the 1940s and 1950s, who publish charts that are very misleading, and um, in order to maybe sell something, or push an agenda. And he goes into like the different ways to spot this, or call it out. So a few examples being like misleading axes on a
Axes.
graph. If you don't start at zero, then you can make a small change look really big, and like, yeah, catch people off guard who may not know to like, oh, watch out for that. And also just like not making maybe limited sample sizes very transparent. You can say like, oh, there was a 33% increase in the efficacy of this drug, but did you run it on like 3 subjects? um, so it's a really cool book to like remind our attention, like push our attention to those caveats that um, that I think are really useful to have in mind when evaluating data critically. Actually, I think before reading that book, I was like first started thinking about this in terms of scientific data. So in grad school, like when I was like first starting out as a grad student, I without much context, like and even now when like broaching a new field, like I kind of have to take on faith what I'm reading because I don't really have the expertise in order to know like, oh, was this data analyzed appropriately, or was it could it have been like misanalyzed in some way? And I found myself in a few instances in grad school. I am like talking to a few lab mates where we're talking about a paper, maybe with the author of that paper, and saying like, oh, like going through the process of their analyses, and at some point finding out that there was like some error in their analysis that
Oh,
made the
word.
results not valid. And yeah, those are really touchy, like understandably, like we all make mistakes. Like I don't judge those people too harshly. But it's really weird to see like, oh, this is like peer-reviewed published paper. But the like it was only once we got to a very technical depth, one of the only few people who also like can critique this method, before we realized like, oh, this conclusion or was not accurate because the analysis underlying it was not accurate. So that was like weird in that once we know that, like no one else knows that that paper doesn't get retracted, because it's like really embarrassing to retract a paper. And so those papers just keep going, getting
And get
cited.
cited hundreds of millions. Well, not millions, hundreds of thousands of times. But
Right, right, right.
yeah, I mean, something that I've become recently familiar with, particularly in academia, is the p-value hacking.
Hmm.
So essentially, like we evaluate 100 different variables associated with an outcome we want, and like probabilistically, like 5 of those will signal as significant, right? And
Yeah,
it's
yeah.
like, hey, we're like manipulating statistics to find something significant, even though like by definition in that circumstance,
Hmm.
like for significance we would expect like randomly 5, right? And to me
Hmm.
that's a little bit of a problem with the way we evaluate our models in general. I mean, I think most data scientists in industry pay significantly less attention to p-value than people in academia, because
Right.
for better or for worse in industry, like you got to test things significantly more, right? You got to like rely primarily on the results and outcomes rather than if like specific variables are relevant. But I mean, that is absolutely being done. I've seen it
Hmm.
done in experiments and been like, oh, like this gives me a little bit more pause. But you know, there's like layers of sophistication with how people can lie with statistics, and it gets scary. And like, you know, like a non-data scientist, probably even a researcher off the street, wouldn't think about, okay, that is a way to manipulate and find something significant in this analysis, when there might be absolutely nothing there.
Yeah, I feel like there are a lot of intersecting issues here. Like one being the incentives. Like we're just like as researchers, like we really want our results to be significant so we can publish papers and just make our lives easier. So you like intentionally or like often unintentionally, like things like p hacking.
Yeah, it's, you want to
That
find
can
something if
happen.
you're passionate about this research, right? Like you, most people aren't researching something that they don't see promise in, right? You know, like let's say I'm like crazy about some diet model and I do research in it, like there's that built-in confirmation bias too, right? I mean, you'd hope that there wouldn't be. And there's some scientists that like are like, screw this, I'm not interested in this, but I want to prove people wrong, or I want to see what an objective truth is. Um, but it's
I
hard to spend so much time not being interested in something you're studying.
totally. I do want to mention though that there is like definitely good progress and movements like to get around this. So yeah, during grad school, I saw more and more labs getting involved in publishing their data so it's open access. And in our lab, like we along with every paper, have a GitHub repo that contains Jupyter notebooks that can regenerate all of the figures. And like there's some scary part of that where it's like, oh, my code is out there. Someone could find the bug that I have in my code because like not everything we write is perfect. But the so it's a little scary, but it's becoming a lot more commonplace, and that's really good to see. So I'm that gives me like more hope in academia and research in the future. Like the more this like open access approach gets amplified.
Yeah, well, to that point, I think historically one of the challenges with academia is that it was sort of this like ivory tower type of thing, right? It's like, oh, there are these PhDs in this closet somewhere, and like they're the only ones qualified to work on this problem. I think now, especially with more of a like Web 3.0 open source nature of things, it's like really beautiful that like I can go work on or try and can help and contribute in one of these projects. And there's like infrastructure in place where people can check it. And like, if I'm doing good work, great. If I'm not doing good work, like you don't have to merge any of it, right? But like, there's such cool value in like hobbyists or people that are just genuinely caring about a problem, doing good analysis and finding insight. Like, I would argue that a room of 200 like like fairly educated, pretty interesting people working on a problem is better than like two PhDs working on it, right? Assuming you could organize those 200 people, right? Because you'd bring different perspectives and different types of things. It's like a pretty beautiful and elegant solution that we're coming to with a lot of the open source problems that we're facing. So I would 100% agree with you. I'm very optimistic about the future of research and information. Um, and hopefully I'll be a part of more of it. I've been kind of taking a break from doing as many projects, but back on the grind soon.
Understandable.
Before I talk to you about Sliced, I do want to get your sentiment about having a PhD in the workplace.
Mhm.
You've obviously, gone through that process. Do you think it's been helpful on the job? Do you think it's something that is worth pursuing for someone that's interested in data science, but not necessarily research? What is your general sentiment um, around going all the way and
Yeah.
pursuing a doctorate?
Yeah, I definitely wouldn't encourage it to someone who's like, yeah, just as a means to progress within data science. Um, but it is I feel like it's overvalued in some sense a PhD, where I've heard some friends like tell me like, oh, I'm joining this team and everyone else has a PhD. Like I'm very intimidated by that. Or like another friend was talking about hiring someone for a specific position, saying like, oh, a PhD is required for this, and I felt like that was a little weird because I don't feel like the like PhD experience is like necessarily like the only way to like yeah be or like a to be qualified. It is unique, um, but I questioned that a bit. Where I think that if just because a position has like a research component. There's a lot of like, if I was a data analyst for 5 years, I feel like there's just as many, like, if not more, like really good skills that I would learn in that position compared to like a PhD that I just have a certificate at the end of 5 years. I think that I personally, when like thinking about like skills and knowledge that are useful to becoming a data scientist, um, that some people may think like, oh, a PhD is especially useful, but I don't think that's necessarily the case.
Yeah. I mean, from a lot of the people I've talked to, it seems like there is a little bit of almost unlearning you have to do.
Mhm.
Coming from like academia for a long time, is that there are like specific systems in place, there are specific ways that you do things in an educational setting that can be very different from what you do in a more like a professional business private sector setting. And I think that like a lot of the things that you pick up are really good, right? Like a PhD signals that someone can dedicate 4 or 5 years of their life to something and like really focus on a problem and solving it. That's a good thing for employers to signal. But the level of structure in most PhD programs is probably uh like very different. And like
Mhm.
you don't have to deal for the most part with Slack messages every 5 minutes and these different types of non-dedicated work that you see in the
Mhm.
workplace. So um I'm interested in your opinion on that. Did you feel like you had to like undo some stuff and like to really come into your own in a more traditional data science role?
A bit, yeah. There's definitely, I think, um, some senses where I feel like I need to understand the whole stack of what I'm working on. That in some cases in a data science role is less practical. Where I'm in grad school, I was used to this, like being the data engineer in some sense and like process making a data pipeline to do this and just being able to be self-sufficient. Whereas, like, I see, like, being a data scientist on some teams uh, can require, like, a lot of like, passing off ownership in ways that I wasn't used to. So, for example, like, I've had friends on teams who, like, as a data scientist, they would request for a like machine learning engineer to build a feature for their model, and then they would have to wait for like 2 months in order to for that feature to be available for them. Where that would like immensely frustrate me. Whereas like I really want to like have uh, like access to like that position too in order to do that. And from like the data pipeline sense, I was in the position at a job where I was told like, okay, here is our like data pipeline, but you don't have to worry about anything before this table. But I had a lot of questions about like how was that table
Made
generated?
you worry more?
And we ended up having issues in that there were like differences in expectation between like what the data science team was assuming versus what like the like upstream infrastructure team was actually producing. So I'd say like I've worked to have like more of a level of comfort in terms of like being being more comfortable um in like passing off work than I used to be, but also maybe like that's a consideration in like finding the positions that I'm most interested in. Like I want to make sure I want to be in a role where like I am doing like some of the analytics and have like clear visibility into the data processing um, as I'm doing like the data science modeling work. I'd be hesitant to take a position if I know in advance that I'm going to be like blind in a lot of aspects.
I really like the selectiveness there. I think that that's something really important, that it goes maybe a level deeper than a lot of people think. A lot of people are like, okay, how much money am I going to make? What is the company name? What are the perks that I get? they're not thinking enough about the specific role. And I've been guilty of that too. Like I took a job a while ago where like everything lined up. It was a really good opportunity, but I got into the work and I was like, I don't like any of this work that I'm doing. Like this does not cater to my strengths. This data is not. I should have done more vetting with the types of things that matter for the work, than for the things that matter like outside of work and for the enjoyment. And I think that's a really important thing to look at and to tease out in interviews or in any of these things is like, what is the job going to be like? How much control am I going to have?
It
How
is
much help am I going to have?
it is really difficult to tease apart though. So I think that's fair. Like often I don't really know what I'm getting into until I'm there. And then
What
I
it
guess hoping there's some flexibility within a role that I'm hired in.
does that, so is that something that you like try and optimize for, is like how much control over the position that you might have, or like seemingly so?
I feel like that'd be really difficult to optimize for. So yeah,
Fair.
I'm not sure yet. I feel like I've gotten lucky in like my experiences so far and being on having managers who I mesh well with.
Awesome. All right. Well, I think we've talked enough about work. I want to ask one more topic, and that is on Sliced. So you obviously competed in this last season. I watched a lot of the episodes. It's kind of a weird time for me in Hawaii, so I didn't get to finish them all, but I caught up a lot on the YouTube channel too, that Nick's been putting out clips on. And I'd love to hear what your experience was with that. You know, like what was like a big takeaway? Was there any, how'd you prepare, those types of things?
Yeah, yeah. So I was on season one, episode one, and uh, like I was getting ready for I think it was 6 p.m. Pacific time. Got a nice cold brew before Nick and Meg sent us a Kaggle link and said like, okay, start. You have 2 hours to build a model and make some data visualizations. Um, and I try to just have fun with it primarily. And that's one thing that like Nick really highlighted. Like, though people can like pick up some some useful data science like concepts and tools by watching other people. Also, a big thing is just to have fun with it. There are people who dress up in costumes. I wasn't that creative, um, but just having like I've never had that competitive feeling like racing to analyze a data set before. So it was a bit stressful, but reminding myself through the process of like, okay, just think of this as like, oh, this is a new data set that I just get to explore for a couple hours. And that is like one of the things that I thought that, um, yeah, I would like to do if I had more time. Just the process of like exploring a new data set is pretty fun. It's like a game.
That's awesome. And so do you think the time limit was appropriate? What do you think is optimal? Maybe like 3 hours, or was it like a pretty good?
I think two is definitely good. More than that, I would start to get tired. Even me, like feel like maybe I have a shorter attention span than most people. But after like an hour and a half, I was kind of starting to check out, and I'd want to move around a lot. So at the first part, I would focus on like processing data and then do some modeling. But I think in both episodes I was in, like the last 30 minutes, I was like, okay, I just want to make some plots right now. There is like a data visualization aspect of the judgment that motivates us to switch around with it. But I feel like I was pretty drained at the like halfway through and especially at the end that um, yeah, more time would be good. But I feel like also less time would be a bit too rushed. So I hope they stick with the 2 hours for the future seasons.
Excellent. And did you do any preparation beforehand? How did you practice? How did you get tuned up for the actual competition?
Yeah, there was a season 0 that they had, the data sets, released on Kaggle too, so I went through some of those data sets and, um, tried to discipline myself to do a mock run. That's like, "Okay, if I just receive this, let me sprint through training a model quick." So yeah, I feel like now there were like 12 episodes in the first season. If people want to like have that experience, there's a lot of data sets for them to go through. And I feel like that's one thing that down the line, I think I'll end up going through several of those data sets just for fun to explore.
Awesome. Do you think that that is an effective way to learn, to give yourself time pressure like that? I mean, I would imagine there are some benefits, but uh, it might not be completely dissimilar to some interview processes.
Totally. Yeah, I would say it's a really nice way to learn in that like each new data set I uh, I dive into, there's usually like some method of processing I need to look up. So I might learn a new tool in pandas, or I might run into, oh, I want to process this text in a certain way. So I feel like it's a good exercise in like discovering some new tools, or freshening up on some things I haven't used in a while. So maybe not so much the time pressure part, but more just the novelty, yeah, repeated novelty of jumping into data sets. And also looking at examples of what other people have done. Like, I feel like, especially as I first started analyzing data, like the things that helped me most were reading other people's code and discovering the ways they're doing them and the tools they're using that I wasn't familiar with. So yeah, watching the YouTube videos or finding the notebooks that some of the contestants put up to see the exact functions that they use. Like I know that some of the contestants were really crazy about an algorithm called cat boost, which I haven't dove into yet, but that's one thing that seemed to work really well. So I need to try that out at some point.
Awesome. Yeah, I completely agree. I think code review is something that I didn't start doing until more recently, like the last couple of years. And I think that that's made me a better thinker, right? Because you can kind of jump into someone else's brain for 30 minutes, 40 minutes, see what they were thinking, and then you're like, oh, why didn't I approach it that way? That's one of the quickest ways to be able to like simulate or try a bunch of different approaches that you might not have traditionally done. And I really love that methodology. I really like doing that. I think I even made a video on it because I was so excited about it. But absolutely, I'm glad you had a good experience on Slice. I'm excited to watch the next season. I told Nick I might even compete in probably season 3.
Do
So
it.
yeah, I'll probably be giving you a ring for any tips and tricks to improve my performance there. Maybe you can distract some of the fellow contestants as well. So, Scott, I really enjoyed this. I don't have any more questions for you. How can people, find you? What's the best way to reach out? And are there any projects you're working on right now that you'd like to share about?
Um, yeah, I think LinkedIn is probably the easiest way to get in touch from there. There's a link to my website, which has my email address. I'm definitely happy to talk to anyone who wants to chat about like fraud detection or data science in general. Uh, Definitely reach out if you want to. As for projects related to one thing we were talking about, I gave my first crack at board game design,
Cool.
making a board game called P Hacking, where it's a competitive game between two research labs who are both manipulating the same data set. And it's a card-based game where basically like I will get to manipulate one data point, and then you get to manipulate one data point, and there are certain cards that allow us to like, oh, make a rounding error or like swap the labels of the data sets. So I'm actually pretty happy with it. Like I feel like the mechanism is pretty like works pretty well in that at the end of the game, like I am trying to get population A to be significantly higher than population B, and you're trying to do the opposite. So there's this like, yeah, this uh, com- like we're adversarial in it. Like I'm trying to increase some samples, and you're trying to prevent them from getting too high. And we're planning out like, oh, which action should we use sooner rather than later. So yeah, I would um, encourage people to check out that I made a YouTube video of
Heck yeah. Shoot
that
that
board
over. I will
game.
link it 100%. That sounds so fun. And
It's
so is it 2 players, or can you have more than that, or what are we looking at?
Yeah, so I did make a mock game manual. So 2 players would be most natural, but I think it can be extended to 4, where it's like 2 teams of 2, and then you basically alternate turns. I'm still iterating on like the specifics. I feel like I need to wait until I like take a sabbatical from my job to like focus on it full time. Um, but yeah, there's a website like OpenCards.io or something. Um, it's linked on my website, but you can actually go in and play like a mock rendition of the game. So would love if people tried it out, gave some feedback, or just yeah, others interested about p hacking.
Yeah, absolutely. I will remind me. I will make sure I link it in the description. I will go check it out.
Yeah,
That sounds fascinating to me. I personally quite enjoy board games and card games, so I've been having a lot of fun. I know. I think Nick did a Catan
mm,
tournament a while ago, and it was before I really knew him well. So I would love to get into the circuit and do some Catan analytics. So
same.
excellent. Well, thank you so much for your time, Scott. I really enjoyed this. I'm super excited for this to come out. Um, I want to check out the board game. I also want to continue to have some more conversations with you down the road. So thank you again.